Hi, I'm Jessica Sklar,
And I'm Brana Butler.
and we're here to talk about our artwork, Additive Mixing. Brana and I met in a session on recreational math at the 2020 joint mathematics meetings. She told me that she'd enjoyed a talk I had given with a colleague that morning. Soon she was showing me her mathematical art, and I was eagerly decoding a cipher contained in Armand T. Ringer, her sculptural portrait of Martin Gardner. During the following months, we became collaborators. Because we live on opposite coasts, our collaboration has taken place via Zoom.
There is a large, vibrant, exceptionally creative worldwide community of artistic mathematicians and mathematical artists. When I began to encounter this community, I was particularly struck by how visually oriented and perceptive many mathematicians are. My sister-in-law observed that mathematics and art both embrace the abstract. I wanted to convey this observation using a simple Venn diagram. Jessica and I began by choosing our color scheme. Red, green, and blue are the predominant colors of the visible light spectrum. Additive color mixing is what happens when lights of different wavelengths are mixed, as opposed to subtractive color mixing, which occurs when paint, dyes, and pigments are mixed. TVs, computer monitors, and other electronics use additive color. If all three primary colors of light are mixed in equal proportions, the result is neutral, gray or white, as in the center of our Venn diagram. This approach to color suggests the intersections or mixings of math, art, and abstraction.
For the math-only region, we needed something that was mathematical, but not abstract or artistic. We chose to make use of the pre-existing math circle, supplementing its curve with 3 secant lines and a tangent line. The slopes of such lines play an important role in differential calculus, and while computing the slope of a tangent line makes use of the fairly abstract notion of a limit, the lines here can be informally described rather concretely. Each secant line connects 2 points on the curve, while the line tangent to the curve at the point P is the line that glances off of the circle at that point. Also, while they are arguably attractive, these lines might not be viewed by many as artistic, so these seem like good choices for the math-only region. We chose to populate the intersection of the math and abstraction circles with a commutative diagram of the type found in category theory, the mathematical theory of structures and systems of structures. This is quite an abstract area of mathematics, colloquially referred to as abstract nonsense, though it is not nonsensical at all. Many category theoretical diagrams are quite elaborate and elegant, but we chose a simple diagram since it lies outside of the art circle. We left the abstraction-only region empty, save for its color, deciding that color itself could be viewed as an abstract but non-mathematical and non-artistic concept. This choice can certainly be questioned. Our perception of color is governed by science. But imagine if you were to try to describe the color red to someone who cannot perceive distinctions in color. You could describe its wavelength, but that probably wouldn't give the person a good sense of how that color appears to you.
Surfaces have been decorated for centuries with tessellations. That is, patterns of repeating shapes that fit together perfectly without gaps or overlap. In 2018, I created a painted, kiln-fired glass puzzle, which includes my tile pattern of fish. I later redrew the tessellation using an approach frequently used by artist M.C. Escher. The rows of fish begin as flat, outlined images and become more defined by light and dark values, suggesting three-dimensional shapes. And in an homage to some of Escher's work, one of the fish finally swims away from the two-dimensional design entirely. We used my tessellated fish for the intersection of math and art in our Venn diagram. As they leave the math circle, the tessellated fish become more three-dimensional and expressive. They leave the constraints of the tessellation behind and eventually escape from the Venn diagram itself. Architect, designer, and inventor R. Buckminster Fuller spoke for many creative artists when he said, "Whenever I draw a circle, I immediately want to step out of it." Abstract art uses shapes, colors, forms, and gestural marks to create visual imagery. There is no attempt to represent an accurate depiction of the visual reality that we see around us. It is an abstract representation of the intangible. My visual imagery for the intersection of the art and abstraction regions does not use any patterns and does not reference the real world.
To fill the center of our diagram, we turn to hyperbolic geometry. In hyperbolic geometry, given any line L and point not on L, there are at least two lines through that point that are parallel to the original line. This is in contrast to the parallel postulate of Euclidean geometry, which essentially specifies that there is exactly one such parallel line. Mathematician H.S.M. Coxeter's work, Crystal Symmetry and its Generalizations, contained this tiling of the Poincare disk model of the hyperbolic plane with 30, 45, 90 triangles. The notion of hyperbolic space is rather abstract, and the image has great artistic value. In fact, Escher used it as inspiration for his circle limit wood engravings after Coxeter sent him an image of the tiling. Our pattern for the central region of our Venn diagram is a portion of Coxeter's 30, 45, 90 tiling. Our choices for this piece were subjective, and viewers may disagree with some or all of them. We would be thrilled by this, since the purpose of the piece is to encourage discussion rather than to assert facts. You can download a template for your own design at the link you see below. Here is a version by physical chemist Michael Ribbick. You can find our piece, Additive Mixing, in the JMM 2021 Mathematical Art Exhibition and in the article Math, Art, Abstraction, A Conversation with Bronna Butler, in the February 2021 issue of Math Horizons. It will also appear as a fabric page in Mathamalchemy, a planned large multimedia art installation celebrating the creativity and beauty of mathematics.
You can find out more about our work by following these links.